All right. So just a few weeks ago, I finished and launched a book called .NET Devops for Azure, and today, today I'm going to be reviewing that book and talking about the high points, and it really answers the question: how do I put together a complete DevOps ecosystem on the Microsoft platform? And so that's the topic. Feel free to get in touch with me on Twitter at Jeffrey Palermo or on my blog, jeffreypalermo.com, or even my email address there. I'm happy to. So there's some email addresses that you'll probably want to note. Some URLs that you'll want to note here on the screen from bit.ly/.NET DevOps book, where you can go to get the book right now. Um, we released it at the Build conference a few weeks ago, and autographed copies and whatnot. It was announced in the .NET Roadmap session that Scott Hunter and Scott Hanselman gave. You can go on YouTube and watch that session. But we had preview copies, and so it'll probably be another month or so before it's on Amazon. But you can go to this URL and you can do a print on demand straight from the book manufacturer right now. And you can also, if you go to the URL .NET DevOps ebook, bit.ly/.NET DevOps ebook, you can also download the PDF ebook. We'll have it in EPUB and Mobi format after a while. We're kind of going through the process. But what it provides is a complete DevOps environment. We want we want you to fall in the pit of success. And really, the problem statement of the industry is there's so many things involved in setting up an automated DevOps pipeline. I really thought about what 80% of the cases needed, and was there a normal configuration that could be had? And the answer is yes. Uh, and there's all kinds of different application formats, but there's thousands and thousands of development teams that have web applications that use SQL Server and have some type of offline job and some combination of those. And so while we don't cover explicitly desktop applications or Xamarin applications with iOS and Android, we had to pick some application architecture, and that's what we picked because it's the most common. And so we picked .NET Core, SQL Server Database, Azure, and infrastructure as code patterns to automatically create environments in Azure so that nobody had to go into the portal and create those environments for themselves. So the hope is that you can take the project in this book and just copy it, literally use it as a starting point and copy it. Um, and so you can go to bit.ly/.NET DevOps project in order to do that. All right, so let's just get into it. Now, along with along with so many technologies being out there, and the answer of it depends. Um, Also, we have a situation where the industry is growing by leaps and bounds, just massive growth, absolutely massive growth, and um, we don't have more experienced developers leaving. We just have a massive influx. And so what happens is this Stack Overflow data on the screen. You can see the number, the percentages of developers in a particular years of experience. So I've been a computer programmer for over 22 years, and I was not taught in my professional in the schooling. I went to Texas A&M University, and I got a computer related degree. I was not taught how to set up my own environment for development or operations. I learned that kind of on the job. I think most people do. So even the people coming today out of school are not being taught how to set up an environment for themselves. And so in order to set up our teams for success, we have to do that. We have to set up an appropriate environment. It is our work environment. It's our workshop. I mean, if you work on cars, you think about, okay, what tools do I need? Do I need a lift? What kind of tools in my toolbox? Do I need any spare parts? You really want to equip yourself, because otherwise you get started and realize, oh shoot, I can't even get started. I'm missing a tool, or I'm missing a part. So I also want to address something that in the book we address this. this common glyph. It's actually on Wikipedia for the symbol for DevOps, and this is completely wrong. This shows a development group and an operations group and a process that goes around both of them, which is the wrong way to think of DevOps. DevOps should be a single process where the same team does development and also runs the system. Actually, the Scrum process got it right. It was just never implemented. Scrum called for a cross-functional team that had all the skill sets necessary for what the software needed. But the cloud has really enabled the true vision of a cross-cutting team or a cross-functional team to be a reality, because when you need skill sets to procure and screw a server into a rack or even manage VMware or Hyper-V, the skill sets are just so divergent that it makes it hard. Whereas with the cloud, now everything, absolutely everything is code. So we have to know what code to write, and we also manage the environments with code, but absolutely everything is code. And so um, we need to move from that kind of process to more of this kind of process. And where we have around the outside plan, code, integrate, package, release, operate, learn. This is the model of DevOps that I espouse in the book. And essentially, it starts in the center as with the automated DevOps pipeline, but that's not enough. We also have five critical other layers that need to be part of our environment: best practices, defect removal, team workflow, architecture blueprints, and cloud operations. And then for each layer, we need a strategy. In other words, we need to figure out what we're doing in that layer. Then we need to execute it consistently, and we need to measure it so that we can manage it and tweak it along the way. Uh, Before we dive in more, I want to talk about the process view for your DevOps pipeline and how you put things together. And this really espouses the first way of DevOps, which is flow, how to flow things through out to our users. And it starts with figuring out what the heck we're going to change, what the heck we're going to build. That's conceptual definition. Then we need to figure out how our users are going to use it. What's it going to look like? Is it a 3-screen progression for certain transactions, or is it a 1-screen type of progression? Or does it not even use screens? Do we integrate with a Amazon Alexa and let them talk to the computer, let them talk to the software? After we figured out how the people are going to use it, then we make whatever key technical decisions are necessary, what libraries we're going to use, build versus buy, patterns. Once we've done that, then we fast forward mentally to a time when it's done, and we say, okay, how are we going to test this thing? What is our acceptance criteria? Let's really figure out what it means to be done with this thing. Once we've made those 4 categories of design decisions and planning, then it's ready for a developer to write the code to build it. And so the developer is going to do some stuff and put code um, in Azure repos in a Git repository. Then after that, we're going to have a build process. Build process is going to produce a set of release candidate artifacts. We're going to put that in the Azure Artifact Service. Then we're going to deploy it to our first line environment. We call that the TDD environment, which stands for test driven development. For that, in that environment, all we have is test automation. There's no manual people. There's no humans allowed on that environment type. By the way, you'll never have fewer than 3 environments in a DevOps pipeline. Everybody knows production. That's an environment type. The next environment type back from that is the manual test environment. And then the next environment back from that is the test automation environment. And you can have as many of each type as you need to, but you'll never have fewer than 1 of each of the 3 types. And so we'll deploy along the way. And then once it's production, then we flow through and we operate the system and we support it. So the physical view of just our baseline infrastructure and products is all 5 of the Azure DevOps suite: Azure Boards, repos, pipelines, Azure Artifacts, Azure Test Plans. Then we have the Azure, the Azure data centers themselves. Obviously, Developer Workstation is part of our environment, and then we have application insights for gathering telemetry and log analytics. So let's dive into what the heck DevOps is, and we're going to start with the first way of DevOps, which is flow. And flow is all about creating that assembly line, that smooth running pipeline from deciding to make a change all the way through to a production environment where people are actually using the software, and everything in between is smooth. And so there's principles like making all work visible. It incorporates lean principles of stopping the line if there's a problem, so that we can make sure that the line is continuously flowing all the time. We don't want fits and starts. We want a smooth flow. Imagining water flowing through a pipeline, and you have a certain consistent throughput, a consistent rate of that water flowing through a pipeline. We don't want changes in velocity. We don't want fits and starts. If any of you are big into computer networking, uh, a ping is how fast we can get to a server and get a response back, whereas network jitter is the difference or the variance in essentially pings, the variance of packet flow from one network device to another device. And networks can be turbulent. They don't work so well when you have a whole lot of jitter, when you have certain packets arriving in 3 milliseconds and other packets arriving in 500 milliseconds. The network just doesn't work that well when you have jitter. But the same thing with human processes as well, which this is a human process. We thrive the best with a smooth and predictable flow. And that's what we're looking for here with the first way of DevOps. The second way of DevOps is feedback. And that is, okay, um, we, we have uh, we have things that we're flowing through, but are we getting feedback? And not just from feedback from operations, but feedback all along the way, from the deployment to the TDD environment, from the deployment to the UAT environment. And so when you think about ops, you know, you are actually operating multiple environments, not just a single environment. So we need to get feedback along the way, and static code analysis can be a form of feedback. Different test suites are feedback. Formal inspections can be feedback, and definitely human feedback from a UAT or a manual testing environment. The third way is continuous learning. And once we have people using our software, or our software is running in a real world scenario, then we need to bake in mechanisms to learn about how it's going. Um, are people using all of the features that we've actually developed, or are some of the screens literally never used? That's one type of learning, so that we can clean up the software. Or are people having trouble? Obviously, we want to capture exceptions, and anytime someone's getting an error, but are people having trouble? If someone's trying to log in, do you have patterns that detect if they how many times they're retrying their password, or have to try something and use the back button, and you go forward and use the back button? Those can be indications of problems for our users. Do we have mechanisms so we can learn how the software is actually doing? That's the third way. That's continuous learning, how to get data back into the learning path to decide what to change next. So um, in the Microsoft ecosystem, uh, this screen roughly shows how your system is going to look in a DevOps environment, just from major components. Obviously, you're going to have developer workstations. Azure DevOps Services is your kind of orchestrate, your brain. It's the brain, the orchestrator brain of the DevOps environment. You're going to have a certain number of build agents. The more, the better. By the way, the hosted build agents are great for various environments like Mac and Linux, um, and even Windows, and they work. But they have a high cycle time right now, and the Microsoft team is working on it. So in a real implementation, and certainly all the teams at Microsoft use private agents, because you have dedicated machines that are always there. They can make use of caching. You can control the horsepower of the machines, and they don't have to start from absolute scratch, from absolute re-provisioning every time. Um, so make sure that you are using private build agents. Otherwise, you won't like your cycle time. And then for deployment, most of the time, you're going to want a combination between the Release Hub in Azure DevOps and Octopus Deploy. which does really well for VM-based deployments. But if you're going 100% to Azure PaaS, then the release hub inside Azure Pipelines does really well there. You'll just do a little bit more work when deploying to virtual machines, and Octopus Deploy integrates nicely. You can get that from the marketplace, from the Azure DevOps marketplace. And then you have your environments, which I show here as VMs, but works great with PaaS. And then for your intelligence, for your continuous learning and your uh, centralized telemetry store, I put Stackify here on, but application insights, Stackify, New Relic. There's several of these what they call APM, or application performance monitoring products. But the gist is, you want all of the environments to be sending all of their logs and all their telemetry to a single place that then you can query, and you can configure queries with thresholds attached to automated alarms that can throw off alerts and send notifications. And you want your development team to be able to query and access uh, all of the logs and telemetry and data about your environments. And that actually gives a wider pool of people the ability to support your environments without actually having administrative access directly to all of those environments. All right, so let's dive into each stage of the Azure pipeline. I'm gonna walk you through the book, and this literally is a walk through the book, chapter by chapter. And if you go through the book, you will see um, that these graphics are in the book, and I'm gonna walk you through chapter by chapter. So overall, when you provision Azure DevOps Server or Azure DevOps Services hosted in the cloud, which, by the way, it, if you want to experiment locally, you can download Azure DevOps Server and you can next finish and install it locally. All you have to have is a SQL Server Express locally, and then you just configure your own workstation to be a build agent, and then you have a standalone build server. So it really is an easy install, even if you want to install it locally and just play it around with it locally. But you want to make sure all of these services are turned on. And from a licensing perspective, if you have a Visual Studio Enterprise subscription or MSDN subscription, then you're already paying for all this. You already have this. So just go ahead and provision it and use it. Now, just jumping into Azure Boards, this is the process that you're going to want in general. Now, there's Scrum template, there's the Agile template, there's the CMMI, and then there's the basic process template. In general, the simpler, the better. If your team already uses Scrum, go ahead and use Scrum. But if you don't, then, and if you aren't using the lexicon of epics and features and product backlog items, just go for the basic template, and you'll just have issues. You'll have, I think, epics and issues. And ultimately, whatever you call it, you typically just have one level of hierarchy. And teams that really get down the road and are hitting a good stride, often that hierarchy starts to diminish as well. But you might have a feature level item that's pretty big, that's a business scenario that maybe is the vision of a use case. And then, but it's too big to be implemented as one thing. So you break it up into individual items. You break it up into user stories, or individual items that can be implemented. But let's go through with the process that you want to model on your board with the various columns. You want to have 4 columns of design before your development column, before the column where all of the coding happens. And so those 4 things are conceptual definition, which is what the heck am I building? What the heck am I changing? Let's make sure we understand it, understand what the business objectives are. Then user experience design, which is an analysis of how the users are going to use it, what their experience is going to be like. Then technical design, which is any key technical decisions about how to implement this thing, any libraries we're going to use. And oftentimes that's where, if it's too big to implement all at once, that's where it gets broken up into individual user stories. And then test design, which is, okay, what's the acceptance criteria? How are we going to test this when it's all done? And I can't stress enough how important these first four columns are. And I don't care what you name them whatever you want. But the essence is 1 through 4, what the heck are we building? Number 2, how is it going to be used? Number 3, what technical decisions need to be made as a team versus whoever happens to be writing the code. And then 4 is what does it mean to be done, and how are we going to test it when it's done? You have those 4 decisions, and anybody who works on the code is going to have all of the information necessary to go fast and not have to stop and try to catch up on those conversations. The columns after development are pretty well pretty well represented out there in the industry. Everybody does, a few levels of testing. There doesn't seem to be a whole lot of missing process as an epidemic, but the columns ahead of development, I would classify that as an epidemic in our industry of just people who have one column of, hey, let's prioritize and then toss it straight into development, or have a sprint planning meeting and let's get straight to coding. And they don't separate these 4 types of design. And it doesn't matter if you have a really small team. You could get through these 4 things pretty quickly with some conversations if you have the users right there in the room and it's pretty simple. But if you omit one of these, you're just gonna incur technical debt. You're just gonna kick the can down the road, and it's gonna be found later on, and you're not gonna have that smooth flow. So again, the first way of DevOps is flow. One of the principles is make all work visible. And if we need an architectural spike to figure out if a certain library is going to work for digital signatures or file storage or whatnot, then guess what? A story is going to be stuck in technical design until we can make that determination, because we won't know what code to write until that decision's made. So from a making work visible perspective, which, by the way, that principle is talked about a lot in the Phoenix Project book, which I highly recommend you read. It's called The Phoenix Project. And and when we make all work visible, we can see where the bottlenecks are, and we can see what's going fast, and we can get better at flow. All right. So once we arrange our work, then we need to arrange our version control system. This here on the screen is essentially your model for how to segment your software into version control. Now, the book gives all the examples using Git, because that's probably the most popular and the new industry standard. And but there are ways to organize your Git repository. And again, all the guidance in this book is meant for the 80% case. Hey, you know what? Most of the time, 80% of the time, you want to do it this way. If you have a specific scenario where you know why you're going to do it a different way, okay, go ahead, do it. But you know why you're going to do it that way. Most of the time, for most people, do it this way. And that is, you have a software system that's broken up into multiple applications. But each of those independent applications has its own Git repository and is developed by a single team. And so if you have a massive software system that is running a big swath of your company, you might have one application that's used by a certain section, certain department of users, and it has a certain technology stack, and you have another application that has maybe a slightly different technology stack. And so they're different applications and they're deployed at different cadences, but conceptually, you group them as a part of this larger software system. A single software application is going to be contained in a single Visual Studio solution. So essentially, one Visual Studio solution should have its own Git repository, and a Git repository should only have one Visual Studio solution. And that Visual Studio solution is a versioned software application. Now, you can have a web application. You could have several offline jobs in your databases. And so you have multiple processes in that, multiple deployed processes in that application, but it is a single application. Now, if you've been doing software more than 10 years and went through actually more than 10 years ago, the service-oriented architecture, or SOA, conversation that the industry had, there was a lot of talk about what made an independent autonomous service. And you can think of an application as the same concept as an autonomous service. And it is deployed as a whole. It has everything it needs to operate. And microservices kind of has the same thing. A microservice is an independent application, and it has its own Visual Studio solution. One of the things with autonomy is that, you know what, if you want to have one of those applications, one of those Visual Studio solutions using ASP.NET MVC, and then another one you want to move over to ASP.NET Core with .NET Core, and then you want another one to be maybe some web APIs and a Vue.js SPA UI. You can vary the tech stacks because you're in a different Visual Studio solution. Each one of those is in a different Git repository. And that's the springboard for the automated part of the DevOps pipeline, because a single Git repository should have a single software build. And so you see how that correlates. And then, of course, you don't want more than one team making changes to a single Git repository, because that's just an organizational recipe for chaos. All right, so let's jump over to how branches would affect your Git repository and the structure thereof. So this is a flow for a feature branch, because a lot of people are moving to trunk-based development, which, by the way, it's a terrible name. Trunk-based development, I cover it in the book, has tons of branches. Trunk-based development just means that while we do everything on a feature branch, all of our branches are very short-lived, and we do a single feature or a single user story, and then we get back to the trunk, or we get back to the master branch as quickly as possible. So when you do that, you branch for a particular user story or product backlog item. You change the code. You do the private build on the engineering workstation, like here in the graphic. You do your commits, you push, then the build server does a continuous integration build. Then your TDD environment automatically deploys it, make sure that what you did doesn't break the deployment. Then we run our automated acceptance test suite against the fully deployed application in the TDD environment. And then once that's done, as the developer, you create a pull request and submit that to the team. And of course, if that pull request is accepted, then that branch gets merged back into master. We'll come back to how to parallelize TDD environments so that you can have multiple feature branches going at once a little bit later. But this is how to manage version control and how to think about that. And that's covered in the book. Now, the master branch lifecycle is a little bit differently, because in master, we're accepting pull requests. And of course, the Git repository does an automated merge. And then we do a continuous integration build off of the master. And then we do a deployment. And then we, of course, run the automated acceptance tests in the TDD environment. And then those release candidates that originated from the master branch, they have the option of moving forward and being deployed to UAT and beyond. Release candidate builds off of a feature branch are not considered release candidates. They're not candidates for release. Only builds coming from the master branch are candidates for release. Okay, so a lot of the work in the automated portion of the DevOps pipeline that we'll talk about next really covers one column before development and one column after, and that is the test design, development, and functional validation. The test design is where we figure out what our acceptance criteria is, and we actually enumerate what our full system acceptance tests are going to be. And those full system acceptance tests have to be, as part of the definition of done for a story or a backlog item, have to be developed, have to be coded with the user story, because they have to run in an automated fashion in functional validation. All right, so let's go over the continuous integration build. So there was a book in, I believe, 2006 called Continuous Integration by Addison Wesley Press. There was this notion of the commit stage of continuous integration, and it covered private build and a continuous integration build. And so there are some different steps in a build process. A private build runs on a developer's workstation, and it needs to at a minimum compile all the source code into your assemblies and then run your unit test suites and your component level integration test suites. So uh, before you commit and push any code, you get a high sense of confidence that you haven't broken anything stupid. You run that locally. It's a PowerShell script that you run locally on everybody's workstation. And then you commit and you push on your branch. So you still keep away from master until you benefit from the continuous integration build and the first deployment. But the continuous integration build is going to clean up any of its local environment from previous builds. It's going to stamp all the assets with a version number. It's going to set up its own environment for the database and migrate a local build time database so that it's ready for tests. Then it's going to compile the source code, and we see the arrange, act, assert separation in the build, because every type of verification has that same pattern that test-driven development popularized: arrange, act, assert. And we can see that in a build configuration as well. The act portion is just doing a compilation, and then asserting. That is, hey, let's check a bunch of stuff. Let's make sure of a bunch of stuff. So our unit tests, our integration tests, and static code analysis is another thing that we want to add to the continuous integration build, which you might consider it to be an assert, but in a lot of cases it's just informational and it's not an assert where it fails the build. But once it finishes that step, then we'll publish the test results to Azure pipelines, which also will automatically integrate with Azure test plans, which we'll see in a minute. And then we package up the results of the build for deployment. And then we publish those packages to Azure artifacts. So those are the major build steps, and those are important. You can vary in a lot of different ways, but you need to have those present. Okay, let's talk a little bit about defect removal, because even though we might build and deploy things down and start working on the first way of DevOps, which is flow, we want feedback, which is the second way of DevOps. And we want to detect that a defect is flowing out to our users. So if you think about the pipeline as smooth running water, let's say we get water out of a reservoir or water out of a well. Where I live west of Austin, we have two wells on our property, one at the top of the hill and one at the bottom of the hill, and they are from completely different underground water sources. And one of them just has calcium and needs to be softened up a bit, and another one has iron and it also has sulfur. So that means that everything it touches, it rusts and it stinks. And so each one of them has different filters applied so that the water resulting is actually clean and is usable. And so we have filters along the way because we know, just from the inherent nature of it, that impurities are going to be in the water and are going to be flowing down the pipeline. And we need to stop the impurities from getting down the line. Same thing with software. Because of the inherent process of software, we know that there's going to be impurities, there's going to be problems, there's going to be bugs. And we need to have the appropriate filters to catch those things and stop them from getting out to production, out to our users. And so we need feedback mechanisms to alert us that there are these problems, these impurities, so that we can take action. And so for defect removal, here are some different activities that need to happen in the various environments. In the design and validation step, those 4 columns ahead of coding, one of the design steps that really serves as a validation or a defect removal is that specifying the test scenarios column. Because if we don't have a clear concept of what it's doing, or if we don't have screen mockups or have a clear understanding of how the screens are going to look or what technology patterns are in play, then we're going to have a really hard time coming up with the acceptance criteria or what steps to go through in order to test the finished product, because we're not going to have a clear understanding of that. And so the act of specifying test scenarios is actually a validation that the previous 3 levels of design have actually been accomplished. And we can catch it there before somebody sits down, hands on keyboard, trying to type some code, and then realizes that a piece of information is missing. On the engineer workstation, uh, we have uh, we have coding, private build, and getting get committing and pushing. And the developer trying to change the code, that's another level of validation where um, if we have to stop and have a conversation, then there could be something wrong there. Private build. If a unit test fails or an integration test fails, we catch something there. Um, if we have a just any number, I'm not going to walk through each of those, but there's this process inherently is a set of filters that can take out problems in the code, and we want to make sure that we have a tight, consistent process so that we can do that. All right, so let's move on um, to the next topic in the book, and that is release candidate packaging. The continuous integration build succeeds on the master branch. Now we need to package up. We need to package up the application um, for deployment. So each of the environments interacts with Azure artifacts in a similar way after we've pushed it. So the TDD environment, the UAT environment, the production environment, they're all going to when they start their process of deploying, they're all going to contact Azure artifacts with a particular build number and say, hey, give me the packages. And so they're going to grab those packages, those NuGet packages, and then they're going to deploy them to the particular environment. It is really important that we build one set of artifacts. We store it with the build number, with the build label, and then we deploy those same artifacts down the line. And by the way, if the full system acceptance test build is, if there's a problem in the TDD environment, that release candidate will never see the light of day. It's dead. That version number is toast, and we build a new one. We don't try to fix it. We don't build again, and we don't build to UAT, and we don't do a build for production. We do a single build, and then we deploy that build to TDD. We deploy that build to UAT. All right. So the compilation step, that's key. We only do it once. The application structure in the book that we go through is a web application, offline job, SQL Server database, and each one of those have its own NuGet packages with the name of the component, the version number, and then the nupkeg extension. That's how you say it, nupkeg. And the acceptance tests also get built and versioned and deployed because the acceptance tests for a particular build have to be run and keep those in line. So even though they're not a part of the software, they are a part of our development environment, and they need to be packaged up and deployed as well. This is what it looks like in Azure Artifacts. And you can see I've used NuGet Package Explorer to download and open one of the packages, the UI package. And what you can see is that the DLLs are inside there. A nupkeg file is essentially a glorified zip file. If you rename that file to .zip, you can open it with any zip tool. And so they just contain everything, and you can see that they have version numbers in there. This package is the database package. The stateful storage is just as important as the compute components of the application. And so we need to have the schema stored in the Git repository with the application, and we need to package up the database schema in a package that can be deployed. And so this happens to use the AliSQL open source database migration tool. DBUp is another popular one that's put out by the Octopus Deploy team. And then on the commercial side, the best one out there is Redgate SQL Change Automation. But they all use the same architecture. They have a directory of SQL files that, when run in order, you will come out the other end with a schema that is up to date. And it supports branching and hot fixing, because if you go back in time and you create a database, it will be missing a few SQL files because they didn't exist a couple weeks ago, and you'll get the exact schema from a couple weeks ago. So it's a foolproof method for always having the right version of the schema, and it allows you to separate database additions from database destructions. If you're going to replace columns or split columns, then you can add the new columns, but then you can come back a few releases later and you can remove the columns. Whereas when you're using a compare-based tool that's trying to guess what to change on the fly, there's so many scenarios where it guesses wrong that it's just not worth it. So the whole industry is moving away from attempts at compare-based models like DACPack and SQL source control, and even entity framework migrations that just attempt to guess, more to this explicit approach where a developer looks at what change to make, puts it in a code file, and then when you do a pull request, everybody on the team can see exactly what change is going to be made, and it's no mystery. And then that exact file um, is run on multiple environments before production. This is what the release configuration looks like. The deployment configuration is kind of like a pattern. If we start with the database, we grab the database package, and then we deploy it and maybe poke in some variables. Then we grab the web application package, the UI package, then we deploy it, and we poke in some variables. Then we grab the job package, the offline job, and then we deploy it. And then at the end, we always want to execute a built-in system health check to make sure that the deploy happens successfully and that the application started up and every part of it started up. So this is kind of what the pattern looks like when you're deploying. You grab a package, do what it takes to deploy the package, go on to the next package. The different environment types, there's different operations that you do on each of the environments, and this is covered in the book in the last 3 chapters. The purpose of each of the ones, the purpose of the TDD environment is automated verification, then manual verification, ongoing operations, and you can see the different quality control steps that happen in each of the different environments. We have a checklist of what things to make sure to run in all of the different environments, and you can see that we do fewer and fewer things in production as we go down the line. For instance, we recreate the environment, recreate the database in the TDD environment. That proves that we can always recreate an environment, and then recreating the database, we don't do that in a manual verification environment. We don't do that in an automated fashion because we have human users, and you don't do that to them. You gotta be nice. This is what it looks like from a release perspective. It's very simple: TDD, UAT, production, and then of course it's all triggered off the build. And that's just you will never have a DevOps environment that is simpler than that. You'll have where you have more, and you'll have parallel, but this is the smallest as it gets. You need at least one environment of each of the 3 types. Now, when you're thinking about how to deploy it in Azure, you have a whole spectrum of environments. Now, in your on-premise data center, you have absolute control, but you have absolute responsibility, and you have to maintain everything. On the other end, with Azure App Services, the Azure data center, they maintain everything except your exact code that's running. And then in between is a spectrum of responsibility that you have. The farther to the left, the more responsibility, the more things that you have to personally maintain and patch, and the more things to the right are maintained and patched for you. So it's just a spectrum. And you know what? It makes sense. Every step along the way makes sense depending on what your scenario is. But the trend as we get more and more mature is definitely towards the right, higher specialization from a data center perspective, and hosted VMs in your own data center, or Azure VMs or containers. They provide, even if you wanted to go all the way to platform as a service, they provide compatibility for applications that have extra dependencies that are not quite ready to run in a platform as a service environment. And so the application that we have in the book maps the web application over to a app service web. The offline job maps over to an Azure function running within an app service in the app service model, not the consumption model. So the database maps over to Azure SQL. And then the acceptance tests, those go straight to a virtual machine on the hosted agent, and they actually run from a virtual machine against the deployed application. When we're running our full system acceptance test. This is what it looks like in the. Oh, looks like we have some audio coming through. Let me go ahead and mute you. Sorry about that. And this is what it looks like to run the full system acceptance tests. One interesting feature when you're running full system acceptance tests is that if it's a web application, you're pulling up an actual browser and you're running the full application. And so oftentimes you might want to see what the computer is seeing, what the test is seeing. And so if we drill in on the next slide, we can see a test has actually captured a screenshot of what it is seeing in the browser as we're running those full system acceptance tests. And the Azure Test Plans integration with Azure Pipelines provides attachments to a test run so that we can literally see a screen with a number and a title and a description and a save button. This was actually what was inside the Chrome browser window. It doesn't capture the border of the Chrome browser, but it captures everything. And so we can actually see the steps along the way. We can do screen grabs. So, and capture those with our tests. So obviously, if a test fails, we're going to immediately go in through and say, well, what was it on the screen, and help us out that way. This is another view of what your pipeline is going to look like once it's finished the TDD environment and waiting on UAT and waiting on production approval. You can see the 100% and the beaker on the TDD environment that all of the tests passed. And we're waiting on somebody to click that manual approve button to go to production. I think that's going to be a common approach. And then for the third way of DevOps, which is continuous learning, we want to make sure that every component, every process of our application is emitting telemetry and logs so that we can learn how it's doing in production and how our users are faring. And so we have all of the components emitting information to application insights, and then you can have log analytics compile as many as you need to and have a greater level of scale for searching operational data. Now, you do want a separate application insights instance per environment. That's the way it's designed. You can try to segment the information by environment using a tag, but it really wasn't designed to work that way. Application Insights was designed to work for a particular environment. So you can see in the TDD environment, we have an Application Insights for the actual application and acceptance tests, and then the other environments we have dedicated as well. And then log analytics can be set up to aggregate as much stuff as you want across as many applications as you want. Now, in our application itself, we implement an interface called iTelemetry Sync. And this happens to use the interface method signature that's pretty popular for people using the Mediator library to implement a synchronous application bus. And so this is actually integrated into every command and query of the application so that we automatically get logging of what is being done. It's the object-oriented way to sprinkle in logging throughout the application instead of the procedural way, which is to literally add a code to all kinds of different code files. We don't want to go and be modifying a lot of code files and just manually sprinkling in these log statements and these telemetry. We want to find the architectural pinch points in the structure of the application code and insert telemetry into these places so that they automatically cover everything the application is doing. And so the telemetry client belongs to Application Insights. And we're basically taking the request that's happening, which could be a query, could be a command, and we're sending, just for example purposes, we're sending a trace and we're sending a custom event. And when we do this, our application is going to automatically emit this kind of stuff. And when we run queries, and we can run, this is running Application Insights in the development mode, we can see the metric that was put through and what is captured, even without a whole lot of work, what is going on in the application. if we drill into a database call, we can actually see that the query that was sent from the application process, from the web application process to the database is captured. Now, we don't capture parameters, so we're not capturing any sensitive information because essentially we're using name parameters here with Entity Framework 4. But we're capturing the actual query that we ran and that a dependency was hit. And just look at the left, there's a huge amount of information that is captured automatically when we just hook up application insights to our system. Now, we can see that we are making a few calls, but this marker that is highlighted in yellow, that is an interesting marker. That is a deployment marker. So we can see on a timeline, now of course, this only has a little bit of traffic here with a few dots of usage, but the arrow, the thing highlighted in yellow, is a deployment marker. And we can see on the timeline when a deployment happened to that environment right here in Application Insights. And if we click on that deployment marker, Application Insights actually has all of the information about what build configuration and what release configuration generated the deployment to that environment. So if we see some of the metrics that we're capturing going sideways or moving in the direction we don't want them to go, we might be able to correlate that, oh, this started happening right after we deployed, build number 1.0.705. So we might have accidentally introduced a performance or scalability problem where it works just fine at low scale, but now something's going wrong. So Application Insights, we want all the telemetry flowing there, but we also want release markers so that we can correlate when we've made a deployment, when things might go sideways. All right, so that was a whirlwind tour through the book. And again, you can go to bit.ly/.NET DevOps book or .NET DevOps project. The .NET DevOps project is an actual public Azure DevOps services project that you can comb through the continuous integration setup and you can see the deployments. It literally is the project that was used to illustrate the topics in the book. And I highly encourage you to go to bit.ly/.NET DevOps book and you can order your copy of the book or get the ebook. But if any of you are going to a user group or belong to a user group, tell the user group leaders about the offer. If anyone would like a few copies of the book to give away at the next user group meeting or local conference, then just get in contact with me and I'd be happy to have a few free copies sent over for distribution to the group. So that was a whirlwind tour through the book. I hope the book is useful to everybody. And the bit.ly/.NET DevOps project, that is free to the world. Take it, copy it, clone the Git repository, use the private build script as you would like to, and I hope that it helps. So I know it went a little bit longer than I expected. There's a lot of information here, but I appreciate the attention and I hope this helps everyone.